Where should architectural intelligence actually execute? That's the question I've reached while building the conceptual architecture for the Knowledge API. Hello, I'm Russell and welcome to episode 10 of the Articulate Journal, where I'm exploring what it takes to build an AI native architecture from first principles. Over the past few episodes, we've explored the knowledge model, looked at how AI can reason over architectural knowledge and how we can describe capability behaviour using DCL. Every architecture eventually reaches a point where the ideas have to become software. For Articulate, I want that point to arrive very soon. Architectural intelligence won't simply answer prompts. It will retrieve knowledge, reason over architectural problems, invoke tools, collaborate with people, involve the knowledge model, and coordinate long-running work. Something has to orchestrate all of that. In other words, Articulate needs a runtime. At first glance, it seemed like a straightforward technology decision. Should I use Dapr, Temporal, LangGraph, or Microsoft Agent Framework? There are already several excellent technologies available, so perhaps the obvious question isn't simply compare them. The more I thought about it, the more I realised I wasn't actually ready to compare any of them, because I still hadn't answered the simpler question. What is the runtime actually responsible for? That question completely changed how I approached the decision. Instead of looking at products, I started looking back at the architecture we'd already defined. And something interesting happened. The architecture had already begun answering the question. Articulate isn't a traditional request-response application. Architectural reasoning may take minutes, hours, even days. The capability may need to retrieve knowledge from several sources before it can reach a conclusion. It may invoke external tools. It may collaborate with other specialized capabilities. It may need clarification from a human architect before it can continue. And when something goes wrong, it shouldn't simply lose everything and start again. Without deliberately planning it, the previous episodes had already revealed a set of responsibilities that any runtime would need to support. It would need to coordinate long-running work. It should orchestrate specialized capabilities. It should invoke external tools. It should recover safely from failure, and it should provide a visibility into what is going on. And it should remain flexible enough to evolve alongside an AI ecosystem that's changing almost monthly. None of those describe a particular technology. They describe the job the runtime needs to perform. At this point, I expect the decision to become cleaner. Instead, another question kept getting in the way. Almost every AI framework talks about memory. Conversation memory, working memory, long-term memory, execution memory. Some treat memory as something the runtime owns. Others expect it to live elsewhere. The more I read, the more I realised everyone seemed to be using the same word to describe several completely different responsibilities. And if I couldn't explain what memory meant within Articulate, then how could I possibly decide what runtime would be the better fit? Because I didn't know which responsibilities belonged inside the runtime and which belonged elsewhere in the architecture. So this episode doesn't end with a technology decision. Instead, it marks the beginning of an investigation captured in ADR 0001. We've identified the responsibilities that the runtime will eventually need to fulfill, that the runtime is a significant architectural component, not simply somewhere to execute prompts. And we've uncovered that the next question needs to be answered before any technology can be selected. What does memory actually mean in an AI native system? Because once we understand that, we'll be much closer to understanding what the runtime should own. And only then will we be ready to evaluate the technologies themselves. That's what we're exploring in the next episode. See you then.